test.
One more test. Hello, hello, test.
Testing, 1,
Test.
2, 3.
All right, everybody, thanks for coming in today. We've had a room switch. We are the Microservices and Serverless panel. If you were interested in the other program that was scheduled here, they're next door. But, so what we're going to do today, we're going to have a panel with our illustrious panelists here, very experienced people in the industry. And how it's going to work is I'm going to open the floor to you guys. So if anybody has any questions on serverless or microservices, how they work, what you think, if you want to know what the future is, how they work today, we're just going to open up the floor and for questions, okay? And I'll pass around the mic. So first of all, let me introduce who our panel is. On the far left, we have Dave Nielsen. He is head of ecosystem programs at Redis. I'm sure everybody's heard of Redis, the in-memory database.
And by the way, that's Redis Labs is the company.
Oh, I'm sorry, Redis Labs.
Okay.
The company is Redis Labs. His job is basically to be on the cutting edge. That's his whole job. He helps people adopt this technology. He has to know what's coming down the road. He has to know where the state of technology for anything around web and microservices, et cetera. So he's been interviewed by InfoWorld. He's been on Channel 9. So we're very lucky to have you here. Okay. So, and in the center, we have Eugene Shuvarov. He is a senior cloud architect with Microsoft. He's got 3 publications on Amazon. He's been interviewed with Channel 9 on infrastructure as code using Terraform. And he's up from San Diego. So thanks for coming up, Eugene.
Sure, that's much better than I would have done. So thanks.
All right, and on the right, we have Chris Richardson. I have like 3 pages of bullet points for Chris Richardson, so we're going to have to try and keep it short. He's the author of Pojos in Action, Microservices Patterns in Java, and he's the owner of microservices.io. So if you have any questions after this panel, if you have any questions on microservices in general, this is the first site that I go to when I'm looking for more information, microservices.io. And if you're a Java shop, you should also check out Eventuate. Chris is working on a framework for microservices in Java. Okay, so now that we know who our panelists are, here we go. So we remember what everybody's name is. I'll go ahead and ask the first question, and then for the next ones, please just raise your hand, and we'll open up the floor. So to start it out, gentlemen, why don't we just go down the line? We'll start on the left. Tell me, just as an opener, what are the advantages of microservices and serverless? Why are we bothering? This is a new technology, kind of difficult to learn. What's the point?
Well, okay, so I'm going to give a short answer and let these two fill in the gaps. In my opinion, the point is that as time goes by, we start realizing there's patterns that are better. When we first started building applications, they were really simple. There wasn't a lot to them, and they didn't scale very well, and there was a lot of problems. And as time went on, we realized that, okay, the cloud offers something very wonderful, which is on-demand services, just simple virtual machines, and then you started to see, okay, this is very helpful because I can now put parts of my application on a virtual machine and spin it up whenever I need to scale it. And then over time, we see more and more of this direction of patterns where there's benefits to breaking up your applications into smaller pieces, and certain parts of it might need to scale out in one direction. You might need to have a part of your team work independently, and they might need to manage their own set of code. You might have some old technology that's running in a language that you no longer really want to work on, but you need to support it, so you put that over in its own set of code. And so over time, we've just realized there's all these different reasons why a big, giant monolith is not the way to go, and microservices have helped us achieve those goals and build better applications. And then as far as serverless go, I'll just touch on that. It's inevitable that we will have serverless. I'm not sure where it goes after that, but as we discover more and more components that are either software as a service that we want to embed or use in our applications, or we want to create our own components that we run as a service, we finally got to the point where we have the know-how, we have the technology to be able to spin up and run these little components and not have to manage them ourselves. And so, again, it's just part of a pattern or a direction that we see evolving, and it's inevitable, and it's a good thing to have these options.
Dave, I thought you said you were going to keep it short. But
that is
so you
short
filled
for me.
all the blanks pretty much. But anyway, so in my opinion, guys, it's just really two words. It's basically one is velocity, and the other one is scalability. So in my day job, I work basically directly with customers and partners that really want to adopt the cloud. And so cloud-native infrastructure to them means microservices, be it on Kubernetes, basically serverless environments. So that's what cloud-native infrastructure to them means, and what the reasons they want to basically get there is just to achieve the scalability of companies that are perceived being as cloud-native today. And so also related to that and very important is the velocity of delivery. So if you kind of separate the applications and kind of responsibilities between the team, you're able to achieve that velocity, which is really kind of like the key thing that we're trying to get to with DevOps processes and such. So those would be my top two things.
I have nothing left to say. Okay.
Ditto.
You wrote a book, come on.
Well, yeah, but you guys have said everything. I mean,
That's
so...
it. You don't need the book. We just said it all.
Yeah. No. No, so I mean, so the... I mean, I think, you know, starting from the beginning, right, like this, I mean, this phrase, software is eating the world, right, which every company is basically having to become a software company. And then not only that, businesses need to innovate faster and faster, right, to stave off competition and so on. And that means that we need to deliver software faster with more frequent releases and with much better reliability. And if you're building small applications, the monolithic architecture probably lets you do that, but most interesting applications eventually become very large, huge, you know, multi-gigabyte, million lines of code or more with large teams. And when they get to that size, you almost always need to use the microservice architecture. That's an architectural style that decomposes an application into a set of loosely coupled services that can be developed, tested, and deployed and scaled independently of one another. So that's kind of why microservices, basically enabling DevOps-style development of large, complex applications. And then serverless, that's an interesting one. I mean, I sort of take a very literal interpretation of that in the sense that it sort of lets you deploy your application, which might be a monolith or it might be a microservice architecture, without having to worry about all of those, well, without having to worry about anything other than your code, right? So the runtime is managed, the compute and storage and all of that infrastructure is managed for you so that you do not have to worry about it.
Yeah, I know that we always have fun talking about the meanings of these things, which in the end of the day, it doesn't really matter. It's can you use them, which I've heard Chris say many times. But it almost feels like serverless shouldn't really be called serverless. It should be called something like a microservice, and I'm not joking. Like that really seems like it's the microservice, right? And then,
Dave, I hate to disagree with you.
No, already?
Always.
Now you guys are just freestyling here. Yeah, come on, come out the audience.
Serverless seems like small little things to me.
No, actually, to me that's misleading in the sense that, yeah, like at some level you could view it, yeah, you have a bunch of lambdas, right?
Right.
But I think a more useful way of thinking about a lambda is really as an endpoint, something that can be invoked, right? Okay. And then, because like particularly, I mean, I come at it from the perspective of using the serverless.com project, right, which might have colored my thinking. But there, you package your application up as a zip file, right? So that, you know, and that can be however large you want it to be, and then there's metadata describing the lambdas, the endpoints, the REST endpoints, the messaging endpoints, the timer-based endpoints, and so on, that blob of code exposes. So from my perspective, you can have a monolithic application packaged as a zip file, deployed as a collection of lambdas, right? Or you could have a service that is part of a bigger microservice architecture that is deployed as a set of lambdas.
So in other words, what he's saying is if you want to build a monolith application, use serverless.com.
No. This is what I tweeted about the other day.
Quote that. Go put it on Twitter.
That's a terrible mischaracterization of what I said. No, I mean, I sort of view serverless as orthogonal. So there's two architectural styles, right? Monolith and microservices, and serverless is actually orthogonal to them.
I see why you guys said you couldn't sit next to each other now.
Sorry, I put you in the middle there, Eugene.
It's probably a good thing,
this
actually.
This is all clear,
so.
right? You guys we're all getting this straight, right? I hope you guys are having as much fun as we are.
Okay.
It's too early in the day for this.
Okay, tell you what, we're gonna open the floor to questions. Before we do that, let's get an idea of who we have in the audience today. So who here is actually using microservices in production? A couple, 4 or 5. Who has, it's in the dev pipeline, you're almost there, but not quite prod? Okay, so we're getting there. What about serverless? 1.
Different hands, okay.
Yeah,
or hand.
Yeah, that's interesting. So what about want to get there, but haven't started yet? Okay, good. Good.
Should also ask which platform.
Sorry?
Which platform? Azure?
Oh, good idea. Which platform? AWS. Azure. Google. Other. Really? Other.
What other?
What is other? What is other? Homegrown? Oh. Go.
I'm not sure.
Ah, okay. Yeah, they're popular.
I'm actually interested in microservices and IoT.
Uh-huh.
Okay. So are you going to be using Azure, AWS for your platform? You're going to try and host it in-house?
No platform. No platform, just the embedded stuff.
Right.
Ah, okay. Okay.
And let me just touch on that for a second. Oh, there's another hand.
Apple, we use our own platform.
Which platform? Oh, Apple platform.
Oh, cool, yeah. Okay, just real quick. So microservices certainly don't have to run in the cloud. At Redis Labs, we have a project that we're working on called Redis Edge, and it is specifically to be able to run Redis in the edge, or you can even run it on IoT devices themselves. And for those of you who are unfamiliar with these terms, so the edge might be like your a data center that's out of the cloud, but between your end and your IoT devices and the cloud, almost like a central office that you might have, like a cable company or something like that, or telco. And so it's not technically in the cloud, but it's out closer to the homes, and then therefore can serve you content much faster. And so, yeah, you might actually put your microservice there, and then you can also put a microservice out on an IoT device itself, I suppose, although it's a little trickier, but I imagine you can do that too. Yeah.
Okay. And actually, one more question, IBM. I know they're one of our hosts here. So anybody using the IBM platform? Not yet. Yeah. Okay. So
well, I should raise our hands. We run Redis as a service on AWS, Azure, Google, and IBM clouds. Yeah.
Okay.
So I guess another question would be how many people are using Minikube to at least play around with the space?
Ah, good question.
What do you think? Who's using Minikube?
Minikube?
1, 2?
I got a question for you. How many of you are using Docker Desktop? If you're interested in Kubernetes, that is by far the easiest way to get Kubernetes up and running. Download Docker for desktop on any of your platforms. Go into settings. There is a checkbox that says Kubernetes. You check that box, and you now have Kubernetes running on your laptop. No joke.
Wow, okay.
That just paid for your entrance fee right there.
You're right, it did. Yeah, I'm taking notes over here, thank you. Okay, so floor is open for questions for our panel. Do we have anybody that has any questions for us? Because I'm going to jump to mine. I got a whole bunch here. Okay, yeah.
Whenever I hear people describe microservices, they talk about, highly cohesive units that are responsible for a single business function, loosely coupled from the rest of the other business functions. And it always sounds like they're just describing disciplined, object-oriented programming with a domain-driven design mindset. So if you're going to add the complexities that goes with a network, what other advantages does microservices give you that warrant the complexities you've now introduced with the network that you can't get with disciplined programmers doing domain-driven design, object-oriented programming?
I'm going to let Chris answer that, but I'm going to just point out that you're assuming disciplined programmers. Just saying.
Yeah, I mean, in many ways, sort of the big idea behind microservices is nothing new, right? It is purely modularity with encapsulation. So, in theory, you can get a lot of mileage just from building a modular monolith. But certainly at some point that, given enough time, for instance, like one client I worked with, and they had 100 developers. It was a 10-year-old application. You're now in the space of like multi-million lines of code, multi-gigabyte WAR files, right? And at that point, how long is it going to take to go through an entire test cycle for your application? And so if you look at like what you're trying to achieve today with sort of deploying small changes many times a day into production, and it's going to take more than a day, more than an hour or two to actually test your application, there's a real mismatch between the sort of the velocity that you're trying to achieve and what your architecture gives you. Just because it gets too large. And then there's the very practical problem, which Dave talked to, is, in theory you can build a modular monolith, but we all know that over time, modularity just degrades, right? It's like our programming languages don't really enforce true modularity in any meaningful way. So you can just violate boundaries quite easily. And so module structures just degenerate, and you very easily end up with a big ball of mud, right? So the nice thing about microservices is those boundaries module boundaries are very well defined, right? Because they're service boundaries and they're impermeable. You can't violate them.
Yeah. One of the quotes that I like to repeat over and over again is, if every time you change your microservice, you have to update your other microservices, it's not microservices, it's services-oriented architecture. I'm making fun of services-oriented architecture, so. Nobody seems to laugh at that joke, but I keep telling it over and over again.
Well, I'm laughing.
It's just early.
I'm laughing.
It's just because, we learned a lot from services-oriented architecture, which is you have to be more disciplined about those endpoints. Because in the earlier days, you'd say, oh, we're going to build everything on this. All of our services-oriented architecture is going to run on this one platform. And so you're just making all these choices for every developer, and now they're all bound to this one system, and you just lose a lot of the benefits, and then you do start to violate those boundaries. So I think the point is that the old way of doing things wasn't enough, and making very clear delineations between who owns your service, and by the way, don't touch someone else's, but you can use it as a consumer, is what actually works.
So when I worked on portlets almost like 10 years ago, we had some JSR specifications And even in OSGI also, we have very rich specifications. When it comes to microservices, do we have any specifications like a JS or some numbers that we'll get it from the Java community?
No. I mean, fundamentally, I mean, the microservice architecture is I mean, it is an architectural style, right? It's not an API. And, and to make matters even worse, I mean, there isn't really a mechanical process that when you follow it, you will come out with a microservice architecture, right? I mean, it's just like any kind of design process, highly subjective, based requires experience and so on.
Okay, here we go, another one back here.
So when we work on the monolithic application, so how do we split that into microservices based on domain? Or what is that micro? What is that logical unit? How do you define?
Sure, well, not really sure if there's a kind of like one strict answer, but I think the idea is just to kind of do it gradually, all right? And so I work with cloud mostly, so I guess maybe as a first step, you would just basically implement the basic migration to the cloud of that app. Let's say it's on-prem. And then you decide, maybe I can introduce new services that could actually be separated from the monolith. And should introduce new services gradually, and then once that architecture starts to prove itself and becomes scalable, you see the value, that's when you perhaps decide to go back and just actually split the monolith to break it down to services and really make it sort of like a truly cloud-native application. So that would be my suggestion, just to really definitely don't do it all, just go all out. I mean, especially if it works well. I mean, at the end of the day, it always has to be problem-driven, right? Do you really experiencing an issue? Is there a problem you're trying to solve? Is there, like we were talking about, is there velocity concerns, scalability concerns that you're trying to address? And if there are any, if there are not any, maybe just leave it as is, So, but if there are, just kind of try to address those gradually and just kind of test things out, prove the value, see the value, and then just kind of exponentially expand.
Yeah, if I can add to that. So the key pattern for sort of modernizing your application is the strangler pattern. And the idea there is that sort of, okay, so you've got your as-is architecture, right? In this case, it's a monolith. Rather than doing a big bang implementation, you basically incrementally build up a new application around the old application, right? And there's sort of two things that you can do. So one is, so let's imagine day one you have a monolith and there's a requirement to implement some new feature, that's sufficiently complex. You could actually implement that new feature as a service, right? So rather than like making the monolith even larger, which is kind of the problematic path you're going down, you can try and implement new features as services, and then there's some hard work to integrate them in with the monolith, right? So that's one pattern. And then the other strategy is to just identify chunks of functionality that exist in the monolith that make meaningful services and basically re-implement them as a service. You could even take the code, rip it out, which is a painful experience, but once you've done it, it's now deployed as a service. And you can think of sort of the monolithic application as being the slow development track, right? Because it's complex, unwieldy. And then every piece of functionality that you implement as services is now on the DevOps fast track, right? So the more functionality you move out, the faster your overall development would go. And you probably want to focus on those areas that are problematic, like, oh my God, we have to innovate in this part of our domain, so we'd implement those as services. Or if you have a scalability problem, move that out as a service so that you can scale it independently.
And I'll just add, by the way, go look up Strangler Vine on like Google Images or something like that. It's kind of cool. I was wondering what it was. And you'll see like these vines that just latch onto a tree and then just start growing all the way up it. And eventually they look like the tree, and then they kind of kill off the tree, and then the tree disappears, and then you end up with this vine that looks like a tree. It's kind of weird.
Yeah, that's the metaphor. That's the metaphor.
Right, right. So, but also I'd like to add to that that you know, I ask this question a lot, like what is a microservice? What are you doing with microservices? And you know, I don't have any particular angle. I'm not looking for anything other than, you know, where does Redis fit in? And what I have noticed is that a lot of companies that are big will answer the question and say, well, we're breaking up the microservices based on business functionality. And you know, so therefore, our department will have its own engineers who are implementing what we need at the rate which we need to implement them. So if we need to make some radical, quick changes to the way our security is, it doesn't impact the whole application. We're not waiting for the next schedule. We can get it done right away. Whereas maybe another team, maybe it's the accounting team, they want very few changes, and they may be on their own schedule, or you know, some new feature that's important for getting out to market quickly because it's a consumer feature. Well, you got to get that out on its own schedule. So big companies seem to follow that model, in my experience. On the startup side of things, it almost doesn't seem to matter, like that kind of stuff. Sure, you don't want to have large teams of people, because if you're a larger startup, you might have 100, you know, or more engineers, and you know, there's the concept of like the pizza box microservices team, where you maybe want to have
two pizzas.
Oh, that's right. Yeah, 2 pizzas. Sorry,
too large.
Well,
I think, to be precise,
it depends on if you're big eaters like I am. You need at least 2 pizzas. But the idea is to have a team that's, you know, of moderate size. I don't know, 6 to 8 or 10 or so maybe, and because you just work better, faster, more collaborative that way than, you know, a large team that has too many meetings. So, but startups seem to be more operating around efficiency, also scalability, which has been mentioned a couple times, and also just to mention this idea of what a microservice is. I think it's important, especially at the big company level. But at the small company level, what I've discovered is there's a lot of things that you might think of a microservice, but you might not actually code as a microservice. So for example, like a serverless function itself, is that a microservice? It doesn't matter.
So there's no such thing as a microservice.
Well, exactly, right? So
there's a microservice architecture, which is an architectural style.
And then a bunch of services. I know. I've watched you talk many times.
You that.
Okay.
Yeah.
So yeah. So there's a bunch of services, right? So the idea of how you code these things up as individual microservices, I don't think really matters. I think what matters is this architectural style, but also, and especially at the big company level, you know, that architectural style. At the small company level, it's like, well, I have a problem. Let me go fix it. Is it a serverless function? Is it just simply like a data access? You're going to query a database. Does that have to be a microservice? You know, or yes, you can code it up with the details around your API and make it, you know, a product you own as a team. Sure, you can do all of that, but those questions get answered differently if you're a large company versus a small company.
Yeah, I want to sort of throw in another thing. So imagine like we were all on one large development team, right? Like, you know, our daily stand-ups would be a lot of fun.
That's all we do all day.
Yeah. I mean, that's a slight exaggeration, right? But, you know, the communication of overhead of a team or an organization is like n squared, right? So the idea is that, you know, we would want to break up into small teams, you know, so 2 pizza teams, but you know, 6 to 8 people, right? And you know, we would want to be, and we do it in a way such that, you know, each team was working on a particular functional area of the business, whether that's like order management or accounting. Each team would own at least one service, maybe just one service, and there would be well-defined APIs that would sort of ensure that those services were loosely coupled, so that most of the time we wouldn't have to meet and coordinate work, right? We're all just working, you know, delivering features for our particular functional area with minimal inter-team communication. Because if you think about it, you know, like to resolve an issue on your team, it's just like, hey, what up? Let's fix it. Whereas if you have to coordinate with another team and get something done, well, you have to like schedule a meeting, right, which can take a while. And then because of conflicting priorities, to actually schedule that you have, it might take a while to schedule the implementation of some feature. And so the more loosely coupled the teams are, the more productive they are. And that really is one of the key drivers for adopting the microservice architecture.
Okay.
I just wanted to jump in, and you guys talked about pizza. I heard everybody got a pizza yesterday. Were you guys here yesterday?
Yeah, there were lots of teams yesterday.
I'm just saying, I'm getting hungry. I don't know about you, but talking about food is
some extra pizzas across the hall.
Okay, I'm going to break a rule of panels and inject myself just for a second, because Dave brought up something I think we need to mention a little bit more. This is not necessarily just a technical question. This is a business question also. How and when you move things to microservices, you got to talk to product. You got to talk to the business side and see what their top priorities are. And then from there, you can also adjust that idea with the technical considerations.
Oh, yeah. I mean, that's a really good point, because like migrating to doing an architectural refactoring, I mean, that is time taken away from product development. And the product people will not be happy unless there is you're actually solving a business problem, right? Which might be really slow delivery, right? Or maybe your product has got so large and complex that it's really, well, basically untestable. So every time you release your product, it causes you have outages and customers are screaming at you and so on. So if you have those issues, those are really good motivations for the business to support any architectural refactoring effort.
Yeah, we have a hand back there.
Got a hand here first and then in the back.
Essentially, there is a relationship between code duplication and isolation. I was like wondering where to draw a line, because oftentimes we end up when using microservice architecture, we end up like duplicating pieces of code across microservices. So again, the question is where do you draw a line between code duplication on one side and isolation on the other, and decoupling on the other?
By the way, I wouldn't say that code duplication is necessarily a bad thing. First of all, it could be ridiculous. Like, for example, Simon Wardley has done some surveys of somebody who analyzes corporations and governments and how they behave and work. And he's found that some large companies may have purchased the same software system hundreds of times, okay? Hundreds of times, when they could have maybe had a site license or something like that, because they just didn't know. Obviously, to me, that's an obvious mistake, right? Because just spending extra money for no reason. But there's also other reasons to have duplication. There may be minor differences, or just freedom to choose and change. So there definitely are reasons to have duplication of code. But I think, getting to your point, if you're duplicating by mistake, and now you're just spending extra time coding things, maybe you'll find that out if you start to break up your application or your company into separate services. It might be easier to actually discover that.
Well, I mean, certainly services can share libraries, right? But ideally, those libraries shouldn't contain sort of business logic which can change. So like, you could have a library that implements a money kind of like utility class, right, and share that across services. But because that's a pretty stable concept. Whereas if you had some business rules in a library, that would mean that whenever those, if those business rules changed regularly, that would mean you'd have to like coordinate the deployment of all of the services that use that library, right? And that kind of runs counter to the notion of independent development and deployment. So, things that change are better off implemented in one place as a service.
Okay, we've got a question here in the back.
Hi. We have customers that like to
qualify their software that they get. So if there are any changes in it, they have to check it before they use it in daily use. So how does microservices, or how can microservices address customers with different versions of functionality out there?
So you're shipping a packaged product.
Yeah, right now we're shipping a packaged product.
Yeah.
But if you went to microservices, how would you handle, customer A having a different version than customer B?
Yeah, that's an interesting question. I mean, I think a lot of the discussion we have is always around basically SaaS, right, where you have complete control. I think in many ways, a lot of the ideas of like, say, DevOps and specifically like continuous delivery can apply to on-premise products as well. And the microservice architecture is purely an architecture, right? And so you can build an on-premise product with a microservice architecture. And perhaps internal, and that benefit of doing that is that it can accelerate your in-house development efforts. But then you can still have a regular release cycle, and though there's sort of, I mean, on-premise products are kind of problematic, but it's kind of like just because you have frequent internal releases, and then every so often you can ship to your customers.
Maybe I can take that. So honestly, I would look to automation as much as possible. So basically automating those releases and maybe customizing them on demand. So basically everything is code. Infrastructure is code, just basically deployments is code. If you can codify everything, you can make changes basically very seamlessly. Again, getting back to the velocity of delivery, as well as customization. So I feel like if you're able to actually not focus on like a single package deployment, but actually automating those deployments and really kind of packaging everything as code, that could potentially be one way.
Yeah, I actually don't have any experience in this specifically, but I do know that there are some companies now who are providing on-prem software, or I should say they're providing the deployment mechanism with the software. So in other words, an update would be theoretically not difficult because they're providing you the updating mechanism, and then when they provide you an update to the software, it's just a matter of you choosing when you want to provide that update.
Yeah, one thought I had is like, I think in a sense, certification sounds awfully like testing. And so then presumably right now the certification is manual testing, right? Where they fire it up and they click buttons. And so there you could just say, well, the answer is automate the certification process. So kind of in a sense, there's like each customer ends up having a deployment pipeline that runs their certification tests and before it's actually deployed into their environment.
By the way, I have a question. Can I ask you a question?
Okay.
So when we talk about microservices at like the department level, those are fairly big components, right? I mean, it's an application really in and of itself, which means you could have lots of smaller components within that. At that large component or application level, it probably doesn't make sense to have like an open source component of that size. That's probably too big. But could you have open source microservices? Because then you could say, well, this particular piece of it, I'm getting it from a third party. I don't have to create that from scratch. And certainly parts of your application can be that way, but I'm kind of wondering how large can an open source component of your microservice be?
Actually, Eugene, you touched on something I'd like to come back to real quick. So the idea of having two different versions, one for customer A, customer B, even one for prod, one for testing for customer A, customer B, which I think was the question, that can be handled from a routing perspective also, right?
Certainly that could be handled that as well, but maybe kind of my answer was geared towards the actual generating actual releases. And so, but yeah, routing perspective, and if you want it to be in the cloud, I mean, there's multiple solutions you can devise there. Yeah.
Okay. So yeah, a router could look inside the packets and see what customer it's coming from, route it to different servers that are up there for testing or anything like that. Okay. Okay, we have a question here.
So when do we stop decomposing the components like we do the microservices? So even earlier also, we'll decompose the smaller modules. So now you say microservices and make it smaller. So when do you stop? Like at what level?
Well,
when you can no longer break down the atoms.
Right. You know what's interesting is I guess you could say my area of interest, my greatest area of interest is that boundary between application and platform. In fact, that's how Chris and I met, because it wasn't mentioned in his intro, but we met at something called Cloud Camp about 10 years ago, where you had just bought the domain name Cloud Foundry, if I remember. So Chris was the inventor of the first version of Cloud Foundry.
Classic.
That's right. Classic Cloud Foundry, which was eventually acquired by Spring and then acquired by VMware, and then they relaunched it as the Cloud Foundry you know today. But yeah, so Chris and I have known each other since then. I've followed Cloud Foundry all along the way, and then of course OpenShift, the inventors of OpenShift were actually at that same event, which is pretty cool.
No, it's cool. He stood around and debated the meaning of the word cloud.
Right. It was pretty wild to follow this whole path. But one thing you should pay attention to is the rise of the platform, because we've had platform as a service for a long time, and it's kind of the classic sense of platform as a service, which is built around virtual machines. And then we have containers that are now evolving to basically replace infrastructure as a service, and upon which we will also have platform as a service. And we're seeing that now with both OpenShift now being based on Kubernetes and, of course, containers, and also Cloud Foundry now itself is now running Kubernetes and containers. So the platform is rising up, and it's taking over some of the complexity that you typically will write into your application code. So some of that functionality we talked about, like inspecting packets, all that kind of stuff, you won't do in your application. That'll be done by the platform. If you attend a session on Istio, you'll see that happening in Istio, which is now becoming kind of a layer of the platform on top of Kubernetes. So to answer your question is, at some point, it doesn't make any sense to break things down further because it's done by the platform.
Yeah, I want to just sort of expand on that. I mean, so if you think about one way to think about it, right, is, oh, my application is too large. Well, development is slow because my application is too large and my team is too big, right? So that would be a motivation for splitting. And so in a sense, you split until you've achieved the desired development velocity and deployment frequency, right? So, yeah, I mean, you don't want, the notion that more is better is not a principle that you want to follow, right? Because, the more services you have, the more moving parts you have in your application, the more conceptual complexity you have. And then also from a design point of view, you can end up splitting something that really is inherently kind of a whole thing. So for example, let's take it, take it to the extreme, which is like kind of a classic microservice anti-pattern, where like creating an order is one service, revising an order is another service, and canceling an order is a third service, right? In reality, those are all operations on you guys didn't do that, did you? But you know what? You have a friend. You got a friend, right? Yeah. So, but basically, they're operating on an order, right? And so there's this underlying business object that's in a database that those services are actually updating. And more often than not, when one of them changes, they probably all have to change, and so you've got a bunch of services that are constantly changing and needing to be redeployed in lockstep. So basically what you've done there is violated the common closure principle from object-oriented design, which says that things that change together for the same reason should be packaged together. And so that's sort of, you're getting into like anti-pattern space if you create these excessively fine-grained services.
Well put. That reminds me, by the way, the opposite can occur as well, where you start to, you have your team, and the functionality within that microservice or team grows. Perhaps you have to do something that nobody has ever done in your company before. So, for example, maybe all of a sudden you need to start storing user-generated content in large amounts. Okay. Now all of a sudden you're storing video or large files, things like that. Maybe you've never done that before. So as a part of your team, you start to build this piece of functionality, and then it turns out that it's really completely separate from what you do. So you break it out into its own microservice. Now your team is building and managing 2 microservices. Oh wait, some other part of the company or application would like to use that microservice. Makes sense. That team now splits off from the original team, and now you have 2 separate teams. So it's actually a way for career advancement, quite frankly, because you could find yourself building something new and unique in your company, and it becomes popular. Now you become a rock star. I'm serious.
Wow.
This is a great way.
Can I quote you? Microservices lead to rock star.
Microservices rock stars.
So,
yes,
so basically
this should be
the
a
answer
thing.
there is
this
keep
should be
splitting until you're a rock star.
That's right. That's right.
So now we're changing into career management from microservices.
It's a career. Awesome. It's a career in itself. Yes.
Okay, we got a question here.
Well, it's more of, Dave had a question about open source and what's a service. But I thought about it. It can, and this is sort of my thought in answering that. So take Redis, for example, and there's the upstream version of it. If I have a specific need, and I fork it, I bring up my own version of Redis, and say if the access codes are fronted by some API gateway, I can have 2 different versions of Redis, and I may temporarily want to keep until my changes are accepted by the upstream maintainers. That in that sense, Redis' application is a microservice type architecture as a service. I don't know if that addresses the line of what you were thinking, Dave.
Well, that's one way I would imagine you could go. By the way, there's a module system in Redis I like to point out. So if you have your own functionality you want to build in Redis, you can build it as a module and run it on Redis, and not. And then if it gets popular, they might bring it into Redis. No, that's one way. I was thinking more along the lines of, I have some friends, multiple friends actually, who are building demo apps. Okay, and the problem is that when you build a demo app, you kind of make up these artificial boundaries between your microservices, and that doesn't seem very useful. So what I was trying to figure out is, could we actually build a demo app that's open source that people would actually use? And what would those microservices look like, right? And I think if they're small enough, sure, that's useful, but then that's not really a microservice per se. That might just be a component in your microservices application. But I'm just thinking, have we learned enough about microservices where we know which ones are reusable? Seems like an opportunity, perhaps. I don't know. I keep looking at Chris to see if he's going to answer this question.
Yeah, I wanted to say there's no such thing as a microservice.
Okay. A service, an open source service. Okay.
Okay, so we have time for one more question. We're starting to wrap up. Here we have one in front.
Hi. We have a monolith app, and we are trying to migrate to microservices, but we jumped into serverless wagon before that. So we are like, take some cookie cutter code, and that can be put into serverless functions. So is that a feasible path? Like then you convert the monolith into microservices, which in turn go to the step 3 actually. It's like,
what was the last part?
So monolith, if you want to convert to microservices, before to that we have serverless functions actually. So
I see.
Some cookie cutter code. is that question clear?
So, I mean, what's the relationship between this, the serverless code and the monolith?
Yeah, did it work for you? Does it work well? You had issues?
No, so this monolith app, it's not scaling, and we are trying to identify the parts which can be scaled on its own in like serverless functions. So we have identified some repetitive pattern actually, and that we have put in serverless functions. But so in the monolith, still we have some boundaries which are mixed, which we haven't separated out actually. So this is in regard with the there's nothing like microservice. It's like a small chunk of functionality. So we are taking that out in the serverless functions part.
Yeah. Well, I mean, I think just sort of in general, you have a monolith, you carve off pieces of it to solve problems, right? Either increase development velocity or solve scalability issues. And yeah, those services that you create could be deployed as lambdas or serverless functions.
Yeah, and to follow up, this actually might be a great way to round out this panel, because let's just say you have a startup and you have 20 engineers, developers, and you've broken that up into 2 teams, and you have a monolith. Okay, you can do that. And now you start to break it up into microservices, or into a microservices architecture.
No, you can say microservices. That is a shorthand.
Oh, there are such thing as microservices, just not microservice.
Yeah.
Right, okay.
Yeah.
So you break it up into 2 microservices, but make sure that you understand that each one of those is not a microservice. But you can have microservices, but not one microservice. Okay, so once you've done that, you got your 2 teams. What you might find is that's the perfect structure for you, 2 teams, right? But then within that, you might have a part of your application that needs to scale. You don't necessarily need to break that new piece of the functionality or that existing piece into its own microservice. You might simply say, I'm going to go use serverless functions for that, but those might not necessarily be carved out as their own separate team, separate API, et cetera. You might use those as a part of your one team, your one microservice. And you can call it whatever you want. I don't really care. But it's what value are you getting, right? Eugene keeps getting back to the value. It may not be necessary for you to separate out a team just to work on that component to make it scale, right? My intuition, based on what you've told me right now, is you may have broken things up into too many pieces. That's what I'm sensing from you. Just keep an eye on that.
And just to add to that, serverless may not be, maybe you kind of jumped into something that was so new to you, it was just overwhelming. Serverless just requires different kind of programming approach, just different mindset per se. So perhaps maybe some intermediate steps are in there. I mean, now we have managed Kubernetes on top of major cloud platforms. And so if you go to Kubernetes route, perhaps it's an easier path for you to take to actually get that pieces of the monolith into microservices-based architecture. So perhaps there's just some additional approaches you would need to evaluate. And, probably we'll stop short from recommending which ones, but definitely look into just, maybe serverless is just too much at one time.
By the way, this is a self-serving answer, so I'm going to warn you ahead of time. But I used to give lots of sort of simple workshops on how to scale out your application. And I always said start with a monolith, because breaking up things into unnecessary structure is actually really difficult to undo. So it's almost better to be forced into breaking your application up than it is to break it up without really understanding where the pressures are. But so you build a monolith, you scale, and you start to break apart. I used to recommend Memcache because Redis didn't exist, but now I work for Redis, and Redis does exist, so I recommend Redis. It's a beautiful 6-month Band-Aid. Okay, I'm not recording this, right? My company will let me say this. But it's a beautiful Band-Aid.
Redis is a Band-Aid?
It's a great Band-Aid.
Wow.
You said Band-Aid. Did you hear that?
Hold on.
All together, everybody. Band-Aid.
For those in Europe,
we're on live, Dave.
For those in the UK, I think they call it plaster, actually.
Yeah, I think.
We're talking about this.
It's a Russian word also.
Okay. So, no, what I mean by that, though, is you have this monolith. You have to scale now. You don't have time to wait for re-architecting, right? Throw a cache, Redis in front of that. use Redis for session management. You'll immediately alleviate the database burden you probably are feeling, because that's probably one of the things that's happening to your application. It buys you time. It buys you maybe up to 6 months of scale while you re-architect, while you start breaking things up, because you can't do that overnight. So look for things that will help buy you time between your monolith and the breaking apart that you need to do. And there are other technologies out there too, not just Redis.
Redis is pretty cool, though.
It is pretty cool.
Yeah.
All right, I think that runs out our time. So thank you very much, panelists. We appreciate it. And I assume they'll be around after, maybe outside. You can grab them while they're grabbing something to munch on if you have some more questions. And thanks for coming out.
Great, thank you, Brad.
Change our course with the wind. Found my better me in the small things you see, discovering a home again. When the day fades away and there's nothing left to say, I'll read your thoughts.